as Claudio said, my name's Georgina and I'm a software developer at 8th Light London. And today I'm going to be talking to you about the Elixir Umbrella. In this talk you'll learn how to create an umbrella project, how to release an umbrella, and also how to make changes to it so you can run it in a distributed fashion. And along the way we'll look at whether it's a good fit for the microservice architecture or whether it's actually just a glorified monolith. So first of all, what is an umbrella project? So sometimes a project can get really, really big, and the Elixir Mix Build tool allows you to break down your code into multiple apps with the aim to make the project more manageable as it grows. So Elixir lets you define one root project with lots of different sub-applications underneath, which together make up the final solution to your project. So to create an umbrella app, you just pass an umbrella flag to the Mix tool, and that will create you a root project, which looks something like this in structure. So you have your apps folder, where all of your sub-applications will go, a top-level config folder, and a top-level mix file where you can state project-wide dependencies. It's not really any use without sub-applications, so we need to define some sub-projects. So to do that, we navigate to the apps folder, and then you can create your Elixir projects as you would normally. And at this point, it's worth noting that you can pass all the usual flags when you create your mix projects here, no Ecto, supervisor, create Phoenix projects. So once we've created two sub-apps, our structure will look something like this. And if we drill into those sub-applications, it'll be a very familiar structure because they're just ordinary Elixir projects. The one difference is that Mix is clever enough to know that you've generated the project in the apps folder, so it knows it's part of an umbrella. And as such, if we look at the Mix files for the sub-projects, the build path, the config path, and so on point upwards to the root of the project. And similarly, if we go back to the root of the project and look at the config, it's going to aggregate all of the config for all of the sub-applications. And this gives you some flexibility in terms of running your tests, for example. You can run all the tests in all the sub-projects from the root of your project, or else you could navigate to the particular sub-app you're interested in and run the tests just for that project. So maybe when you're developing a single project, you can develop it and get faster feedback that way. Sometimes we have dependencies between our sub-apps. So we want to have one sub-app use code that's in another one. And umbrella projects make it very easy to have child dependencies. And where a dependency is within the umbrella application, we can just use the in-umbrella true flag, and Elixir knows just to look within that project for it. So this is useful if you don't want to host a library on Git or Hex or something like that. So in summary, umbrella applications help you break down a large, complex system into smaller sub-applications. Unlike sort of traditional microservices, everything is hosted in one GitHub repository. So you eliminate the overhead of managing pull requests, the order that pull requests should be merged in, the order of deploying dependent systems. That's all taken away because everything's in one place. And it's easy to run your tests from different levels and have dependencies between the apps. So let's see how this fared in a kind of side project. So me and a colleague decided to explore the umbrella and create a side project, which we called Faros. And Faros can be summarized as a learning portal where you could save blog posts and you could search for different topics. There was basically just two use cases. This is a snapshot of the landing page. So if you wanted to save a blog post, you would click the posts, and that would take you to a page like this. And you can tell I'm not a front-end developer from the styling. And you put in the blog post that you want to save to read later and press save. And at that point, it would save to a Postgres database. And all of your saved blog posts would be shown to the user underneath. Searching looks similar. You put in the term you want to search for and the number of results you want back. And this is where it got a bit more interesting, because when you press search, we actually call out to various different sub-applications, which in turn will go and hit external APIs. So for the purposes of this talk, just imagine when you press search, it's going out to Twitter, and it's going out to Wikipedia, gathering results, and displaying them back. As it happened, we stored the results for the search in memory just for fun, just to explore GenServer as a way of an in-memory cache. So our umbrella structure looks something like this. We used a Phoenix project for the front end, and we called that faros front end. We had a post service for the blog posts, a DB service for the Postgres persistence, various search sub-applications, and then an in-memory database. Because if you imagine when you hit search or post, it's going to come in through the web app in a controller. Those controllers then delegated to the relevant sub-application. So we had dependencies in our web project of the post service and the search services. And that allowed us to then just call code in those services directly, like at the bottom here. You can just use them as ordinary libraries. So this is a relatively simple project. Why did we even use an umbrella? Well, we wanted to see if it was a sleek solution for microservices, or whether having the code in one repository would actually bring in different problems. And even though it was a seemingly simple project, there was actually a lot of takeaways and lessons learned, and I'm going to share some of them with you now. So the first lesson is around breaking up your project. It's actually really, really hard to know at the beginning of a project how best to split up your architecture, and it's even more difficult to get it right first time. So, how do you know the boundary of each sub-application? There's different ways you can slice it. So we were using a web application. So probably the most naive way we could have split the architecture would have been to have a web sub-app with just our Phoenix layer and a core sub-app with all our business logic. And this way, our web layer would be very thin. It would just have our controllers, routing, maybe authentication, manipulating headers and your requests and so on. And then all of your business logic, like your posts and searches, could be under core, and you could separate them with folders. So you've got less of a hard boundary than different sub-applications. So this could be a good starting point if you're not sure how your project's going to evolve. On the other hand, you could decide to split up your application per responsibility. Perhaps if your domain's a bit more well-known, you can already identify different services. And then there's the question of persistence. Should you have one database service that handles all of your database interaction? Or should you have a database bundled with each sub-application that needs to use some persistence? So by no means am I saying this is how you split your architecture, but just to recap, this is how we ended up doing faros. We kind of went for the per responsibility split, and we decided on having one database service, purely to try something different. In the past, when I've been on traditional microservices, we've always fought to have a database per service, but a lot of the materials I was reading around Elixir were advocating the use of one, because you have one place to start Ecto, one place to manage pooling, and manage migrations and so on. So I thought I'd give that a try. So one thing was really clear is that umbrellas really lent themselves to change. So if you found out you were writing a kind of sub-application and you didn't need it anymore, it was really just a case of deleting that sub-app from the apps folder, and it was gone. We also brought in existing projects under Umbrella. So the Twitter service was already written, and we just pulled it under. And it's just a case of moving folders around and then changing the paths in your mix file and config to point upwards. So it really was a flexible project structure to work with. The next lesson was around Elixir Versions. So in your Umbrella, you can define a different version of Elixir per sub-project if you want. Now, when you define a version of a dependency, you're actually stating a requirement, and you're saying, this is the version that I'm willing to work against in this project. And under the hood, Elixir will call a function called version, which will check that your requirement can actually be satisfied. So most of the time, this works fine. But occasionally, I found I was getting an exception around invalid requirements. And I figured out that this was because I had this kind of scenario whereby I have two sub-projects that are dependent, or one is dependent on the other. The web app was stating it wanted to use one version of Elixir, and it had a dependency on a post service which was using a higher version. So it wasn't able to satisfy that dependency. So this is maybe something that would happen if you're pulling in existing projects under your umbrella. Maybe the existing project's been around a little while and is not using the latest version. So it's something to bear in mind. And my advice here is really to strive for consistency. If you can afford to upgrade your versions and have them all running on more or less the same, it's probably worth doing. The next thing you've got to be careful of is circular dependencies, where you have two sub-apps that are dependent on each other. In other languages I've used, it's not always been that obvious if I've had a cycle, and teams have often resorted to using like code analysis tools, or it's only in investigating a weird bug that people have realized, oh, actually there's a cycle here. And as developers, we want fast feedback that makes us effective. And Elixir gives you really fast feedback for this. So under your umbrella, if you end up with a cycle, you basically can't do anything because Mix tells you straight away that you have to break this cycle before you can go on, and you have to down tools and sort it out. And if you do end up in this situation, it's probably best to check if you've split your services to a too small a level, and maybe the two things that are dependent on each other should actually be combined and they may be related. Another thing we had to battle was transient dependency clashes. So under our umbrella, we have a mix file per sub-application where you can define the dependencies that each project needs. And I was using JSON to parse my responses from the Wikipedia API call. So I wanted to use Poison. And of course, I wanted to use the latest version of Poison, 3.1. Now, if you remember, it's a web application, so we have a Phoenix project as well. So if we skip to the Phoenix dependencies, our front-end dependencies, where you bring in Phoenix there. And when you bring in a dependency, it's going to bring in all of the dependencies it also needs. So you end up with a ton of transient dependencies being pulled in. So if we now go to the Phoenix source code and we look at what the Phoenix brings in, we can see that Poison is also listed there, the second to last one. But it's using slightly different version. It's not using 3.1. So unfortunately, you end up with an exception looking something like this, where it's telling you quite clearly that the versions of Poison are clashing between sub-applications. But thankfully, Elixir has a way that you can handle this. You have to explicitly override the clashing dependency. And you do this using the override true flag. And that tells the project that it should use the version stated here and ignore any other versions. So the overhead here is that in your front-end app, where you bring Phoenix in, you have to explicitly state you want Poison and the specific version that you want to use as well. As well as dependency clashes, we ended up with namespace clashes. So if we look at our search structure, under each search service, we had a module called search. And they look pretty similar, the same interface, but they were going to different external services. So when I ran my Wikipedia tests, everything passed. When I ran my Twitter tests, everything passed. But when I ran from the root of my project, I started to get some failures. So the first thing I did was go back to Wikipedia, run them, they're all good. Go back to Twitter, run them, they're all good. So I was like, what's happening here? So when running from the root of the project, the apps seem to be running in alphabetical order. So the Twitter test would run first, and thus the search module for Twitter would be loaded. Then when it went to the Wikipedia sub-app, the Wikipedia test would run, and it would call search, and it would actually find the Twitter search module, which had already been loaded. So in fact, whichever module was already loaded would basically win. So I was in a situation where my Wikipedia tests were running against my Twitter client. So the way that we worked around that was to actually explicitly namespace the modules so that we had Wikipedia search and Twitter search. The next battle was around cleaning up test data in the database. So we have a few services that actually interacted with the database, either directly or through dependencies. So we've got the database service, which would directly access, directly persist, and fetch from our Postgres database. We have the post service, which had the database service as a dependency. And we had test for post service, which ultimately would put data in the database. And we have our web front end, which has a dependency on the post service, which has a dependency on the database service. So again, we had tests there that were also putting data in the database. And I wanted my database clean at the end of my test run. So after a bit of research, I realized I could use the Sandbox, the Ecto Sandbox, to create transactional tests. So each test would start a transaction, and then at the end of the test, the transaction would roll back, thus emptying the data that had been persisted in the database. And that was fairly trivial to set up. You have to state in your test config that you want to use a Sandbox pool. And you have to get an explicit connection in the tests that will interact with the database. So you can do this in a setup block. And at that point, it sounded like everything should be set up to run transactional tests. But unfortunately, sometimes I was running into ownership problems. So the process, when you start it in your tests, is only started for your test process. So when another process comes along, it actually doesn't have a connection to use, or it's not authorized to do so. So after a bit more research, I realized that the Sandbox was running, but not in the mode I needed. And I needed to explicitly state that I wanted to run the Sandbox in shared mode so that more than one process can use the database. And to do that, you just update your test helper, where you state that you want to use shared mode, and then the test ran and cleaned up after themselves, as I wanted. Something else to be aware of is the boundaries that your tests cross. So another example we have is almost like a full scenario test, where our controller tests invoke another service, like the Wikipedia service, and that actually goes externally to an external API as well. And it's easy to forget how far through your umbrella some of your tests are actually flowing. And we found this a bit difficult when tests started failing, because with this scenario, for example, if Wikipedia had a blip, which it did have a few times, with the Wikipedia test would start failing, but also our web test would start failing, and then you're sort of on a bit of a chase as to where does the problem lie. It wasn't too focused. So we wanted to rein in that path a little bit. And we started to do that by substituting external systems. So here is an example of one of our controller tests. We do a post on the search endpoint and give it the term Elixir to search for. That's then saved in memory. And then we do a get on the endpoint, which would look up from the memory the results that had been retrieved. And we assert then what's displayed back to the user. And the search that we invoke looks something like this, whereby you can see that the Wikipedia search is invoked, and that's the bit that actually goes to like the outside world. So we decided to extract that line, which goes to the outside world under the hood, and wrap that in a new module. And we called that module third-party search. And so we also wanted to provide a fake implementation so that depending on which environment we were running in, we could decide which implementation we wanted. So we created another module called fake search, which just returned a canned result. And then we configured our config such that if we're running in the test environment, we want to use the hard-coded result. But if we're running in dev or production and so on, we could use the third-party search and actually go to the real client. And Elixir allows you to do that. So in your config, you can just state what app you're in, and then a key value pair. So the key is search. So in the code where you see search, it would substitute the fake search in test, and it would substitute the real search in dev. And then you can just look up using application get-env and use that key as search, and then the substitution will be done for you. And that just left us to update the assertions. Because we're returning a hard-coded result here, we just had to update our assertions to reflect that. But it cut out that external call, which shortened the route and put the tests more back in our control, because obviously we're not in control of how Wikipedia will change. So the takeaway here is just to be aware of how far your tests are spanning. It might be fine that you go to the external systems or span multiple services, but just have an awareness of how far your routes are actually going. The last lesson or tip is around documentation. So sometimes troubleshooting took a bit longer than normal. It was a bit of a slog to sometimes get ideas on how to solve some of the problems. And many tips were found through scouring GitHub issue lists and just finding blogs that the community had written. And there were some cases where tooling was kind of playing catch up with Umbrella projects. And you'd have a great long description of how to deploy a vanilla Elixir project, but a line or two for Umbrella projects. And then if the example didn't work, you were back to trying to find a blog or something that somebody had done which explains things a bit better. So now we have our working Umbrella. We want to deploy it. So at first I looked at EXRM, which is the Elixir Release Manager, but it straight away points you to Distillery. And it turns out EXRM does support releasing umbrellas, but you can only do it in the kind of traditional microservice structure, whereby every sub-application would be its own release, and you'd have to release them all individually and then kind of make sure that they can orchestrate and connect together. Distillery, however, sounded like it gave a bit more flexibility, so I went with that and added that at the root level mix file. And once you pull that down, you have access to various release tasks. And the first thing you have to do is create your release config. And by default, all of your sub-applications are bundled together as one release. So here you could say it's a little bit like a monolith. You're just releasing as one lump all your functionality to one place. If you prefer to release each sub-app individually, a little bit like EXRM, you can pass the release per app flag and regenerate your config, and you'll actually see a lot more in that file, and you end up with a separate release for every single sub-app that you have. And the really nice thing is you can do various combinations in between. So here I defined 2 releases, one that had 3 sub-apps and one that just has wikipedia sub-app. So it's really up to you as the developer or your team to decide what sort of topology of releases will best suit your project. So once you've decided on what structure you want, you can actually build your release and start it up. So you build it using mixed release, and you pass the M flag, and that will determine which config is picked up. So here, the prod config EXS will be picked up. And once it's built, you'll get various options on different ways you want to start your application. So you start getting excited at this point because the text is green as well, and green always means good. So you start it up, but of course it fails because programming's hard. So, you have to, this is because this was a web app, and then you have to start troubleshooting all of your release problems. And I can see here that it was falling over because it couldn't find the code reloader for Phoenix. And that's a kind of dev tool that runs. So in development, when you're changing things in your web folder, you'll automatically see the changes on your browser so that you don't have to keep restarting the server. And we don't really want to deploy that to production. It's really something that's just a dev dependency. So we have to do a little bit extra and state the mix env as prod, and that will only include the production dependencies and exclude the dev dependencies, and it will also optimize the beams. So that's something that we want for production. As a side note, if you've got separate releases, you would do this for each release, and you can just pass in the name of the release that you're working with. So at that point, you start the app again, and of course there's another error because programming is really hard, and it's around the assets. So you may need to minify your assets, but also, as stated here, you have to create a Phoenix digest. And that gives a unique name to the hash of your assets, so that should your assets change, the hash will change, and therefore your users will see the up-to-date content even if their browser is caching. And at that point, everything worked, so it actually wasn't too difficult to get a release out the door. So to summarize releasing an umbrella, you as the developer or your team have the control of how you want to subdivide your releases up. And you really can choose to have it like a traditional monolith or traditional microservices and do what suits your needs best. So at that point, we were like, okay, well, we're using Elixir. Let's try and get distribution into the app. So that's where you have like multiple nodes connected. And so we had to think of a use case for this. But first of all, let's just take a step back and kind of see what like a cluster is in Elixir. So if you imagine you open up an IEX in your terminal, it's an interactive Elixir session, and you can access any code that IEX has access to. If we open up a second session, it has no idea of the first one, and they can't actually communicate. They don't know of each other's existence by default. But we can start them in distributed mode, which will allow us to connect them. And you do that by starting a session with a name, and that gives it an identity. So here you can see I've started this one with the name Batman, and then the prompt has the name in it. And the session knows its own identity, so if you do node.self, it will print out the name. And then if we start another session and we call it Robin, Robin knows who he is as well. But they're still not connected, they're still completely separate. But you can call node.connect to actually make them aware of each other. And then if you do node.list, you'll see that Batman now knows about Robin. And node connection is transitive. So if you go back to Robin and list out the nodes that they're connected to, it will include Batman, even though we didn't explicitly connect them together. So basically, anytime a new node joins a cluster, it will have visibility of all the other nodes that are already in there. So we can just define a node as a system running the Erlang VM with a given name. So going back to faros, we decided that the search was maybe a good candidate for distribution, because when you press search, we could actually fire off requests to different servers and have Wikipedia, for example, searching on one server and the rest of the app on another. So if you recall, we have this kind of setup, and we decided on just 2 releases, one with Wikipedia and one with everything else in. Now, if they're distributed, they need to be a bit more clever about how they communicate. With traditional microservices, you really define a protocol up front as to how different services connect. And often HTTP is used because it's a well-established protocol, and you can use ACE. So, however, we were using Elixir. We didn't want to bring in any external dependencies, and because Elixir runs on the Erlang VM, we decided to use RPC, remote procedure calls, to call methods on remote nodes and then collect the results. So here's the changes we had to do to make faros distributed. First of all, we had to create our Wikipedia node. So we navigate to the Wikipedia subproject, and we start an IEX session with a name and a cookie. We'll come back to the cookie in a bit, but if you now remember the name, wiki at localhost, you would then go back to the entry point of your system, which for us was the web app, and we can configure that node name, the wiki at localhost, as a child node. And we actually have a tuple here where we've got the node name and then the module name, because if you remember, we had namespace clashes. So here we state the module that we want to call in the code, which you'll see in a minute. So then we had to update our controller to actually create the cluster. So here the first thing we do is connect the nodes. So you can go to your config and get the child nodes, and then if you had more than one here, you would iterate through them, and you can explicitly call connect to create your cluster. Then we have to update the code such that RPC is used so that the 2 nodes can actually talk to each other. So here, again, we go and get our child nodes, and then we call, which is defined at the bottom, where you can see the RPC call, where we pass in the node, which is wiki at localhost, the module, which is wikipedia.search, the function that's on that module we want to invoke, and any parameters that you want to pass to that function. At that point, you can release the rest of your application. So we've started our front end, and you have to use the same cookie So if you read the Erlang documentation, it's saying the cookie is adding security, and it's a bit like having a passphrase or something like that. When a node is joining a cluster, it having the same cookie is basically it's saying, I know the secret word, so let me in. At that point, you have faros running in a distributed fashion. So there's actually very little change needed, and it was quite isolated as well to allow the search to run in a distributed way. In real life, you'd probably be deploying to something like AWS, but the process, the steps are exactly the same. You would build multiple releases. So here we have 2 releases. You would deploy the first one, so you would deploy the Wikipedia node. You would note the DNS that AWS gives you and configure that as a node in your web app. And then you would deploy your web app configured with that node, and you're in the same position. So, coming back to the title of the talk, is the Umbrella project a good fit for microservices? These days, a lot of projects are very large and very complex. So the ability to break that problem down and actually work on different pieces independently can be really useful. On the other hand, a monolith has a really negative connotation. It's often used for legacy code, something that's been neglected and degraded over time and is now a monstrosity and can't be updated. But if we decided from the beginning to use a monolith, and we were aware of how it could degrade, and we were disciplined about keeping it well segregated such that it didn't degrade in that manner, we might earn the right to call it a majestic monolith. So given the fact you could write really, really terrible microservices or really majestic monoliths, where does the umbrella actually sit? So in terms of development, you could say the umbrella was a little bit like a monolith because it's all in one repository. However, it does separate the applications under the apps folder, so there is some kind of harder boundaries than a monolith. I actually found working with a single repository really beneficial. One of the client projects I'd been on, which used not Elixir but traditional microservices from the start, we ended up with such an explosion of GitHub repositories. It was really difficult keeping on top of pull requests, merging them in the right way. Some services you never even really got visibility of. Whereas I found with everything in one repo, if a change spanned multiple sub-projects, I could make them all in one go. And I could also see what other people, like my colleague, was doing, because everything was in one repository, so you only had to look at one place, and you kind of became quite familiar with it. In terms of the code communicating with itself, well, a monolith has direct access. Microservices, you have to define the protocol from the beginning. And the umbrella, although you need a protocol if you're kind of doing distributed stuff, if you're not, you have direct access to the code just through the library dependencies with the in-umbrella flag. In terms of languages, a monolith is typically one, and microservices have the ability that you can use different languages, which could be useful if one of your services is doing something that a particular language is really good at solving. With the umbrella, you're kind of tying yourself into languages on the beam, but we all know that Elixir and Erlang are super cool, so it's really an advantage. And in terms of releases, this is where the umbrella starts to shine. So a monolith always shipped as one. The microservices are shipped as separate pieces, which you then orchestrate together. And the umbrella is really as you define. So we saw how we can split them in different ways, which I think is good that that's in control of the team to decide. So in summary, I found the umbrella really interesting to work with. I felt it had the advantage that everything was in one repository like the monolith, but you still had separate boundaries within your sub-apps. So the coupling was still fairly loose between the components. The flexibility in deployment was a plus because you could deploy everything to one server or multiple servers, and even changing the umbrella to be distributed was very little impact. So I definitely think they do work well as a microservice architecture, but they have the advantage of being on one repository like the Monolith. So for me, they actually combine the best of both worlds. So perhaps I should have actually named this talk Majestic Microservices. But it's really up to you, and you should give them a go and see where you think that they fit best. Thank you very much.
Thank you. Thank you. Any questions? Yes, look at that. Wow. Okay, I'll start from here.
Thanks for that talk. That was really clear. Just one thing to note, not really a question, but a comment. One other gotcha with umbrellas, which you didn't mention, is that config is global. So we ran into this problem because we're using a global logger application, and we wanted to configure it differently in different apps, but then you have one of those configurations will win and clobber all of the other ones. So it took me a while to debug that.
Yeah, because all of your paths point upwards, and they're actually all stored in the same place. Yeah. Thanks.
All right. Please. Okay. Thank you.
Hi, very useful talk, thank you. Just one quick question. In your examples, you used two level of nesting, so you had an app with a sub-app. I presume you can actually sub-up the sub-ups as well, and everything will work in the same fashion?
I don't think you can have an umbrella in an umbrella, which I think is essentially what you're asking. Yeah, you can have multiple Phoenix apps in your umbrella. So if you've got like multiple front ends or like different views and like admin or two web sort of entry points, you can do that. But I don't think you can nest the umbrella structure.
Not a sub-umbrella as such. Oh, thank you.
Yeah.
Okay.
Very good talk, thank you. I've not quite got a question at the end of this, but one of the things that I've not really seen discussed in umbrellas or any of these security. So especially if you're using the umbrella kind of approach, it looks really attractive, and but you've got no security unless you add it yourself for calling across boundaries. So I wonder, I suppose the question is, did you come across that here? But my thought would be, imagine I'm designing a typical front-end system. Maybe it's got a web bit, and it's also got a payment processor, and it looks really attractive to build that all as a single umbrella. But I'm left with the possibility that if somebody were to find a way of doing a sort of local code execution somehow in my web app, they can call any module anywhere inside the umbrella, so they've got full access to call my payment processor module that might also be within that. I wonder if you've given any thought to that or have any suggestions.
So this project didn't have any security, but something that comes to mind is, because I think you'd get this in any project, or even if you had everything in one Phoenix app, you'd have maybe the same risk. But if you're, say, deploying to AWS or something, you can shut down security at that level, so you can't have external connection to the server that you're deployed in. So you could do something like that, perhaps.
But I'm not sure you can, because imagine you host on one AWS node your payment processor, and you host on another your web interface. Because you've set up a cookie between the two, if somebody were able to do things that you didn't want them to do with your web front end, they do have the ability to call straight into all of the modules, including all of your private functions, in the other AWS node. And that's one of the things that I see. Yeah. Obviously, you can build internal security, but it's not something that comes out of the box.
Yeah, I haven't explored it, but yeah, interesting question.
Tess? Yeah, that's just the way Erlang works. I mean, it's, you share the cookie. It's more for partitioning than a security mechanism. There's nothing there.
Okay, and any questions? No, oh, wow, okay. So let's take the last one.
Hi, thanks for your talk. So our team, we've been using GenStage as under an umbrella for our separate applications. is we've already spent about a month just working out the infrastructure to deploy it and just getting around the testing part of it. And we keep cycling back to the same kind of question of just a bit of self-doubt of, are we building it in the right direction as opposed to a monolith? Because, I mean, our applications are each so small, doing such a like a granular, like fine-grained a function, and so I mean every few days we keep questioning it: should this all be wrapped again up into a few applications? So I'm just wondering where do you kind of draw the line? And yeah, I mean I was hoping that. I guess it's so new that there hasn't been many projects actually gone into production yet, so we're just kind of on that edge there. So just wondering where you would kind of draw that line.
I've had the same thoughts because some of the services that we wrote were tiny and really just delegating to another one. I don't know the answer, but maybe if you've got, I mean, I think there are some advantages over an umbrella versus a monolith in the sense that if you've got quite distinct areas of your application, and so it's such that you've got two different sub-apps, they can be, like in your team, you can split the work quite effectively and you're not treading on each other's toes, and you can like work in parallel and so on. But at the end of the day, it is really just a glorified folder structure. So yeah, I think it probably is a bit trial and error. But I do like the fact that you have sort of harder boundaries than a monolith. So even though you can basically achieve the same by having a monolith which you break up in different folders, it's not like strict, and your abstractions will leak potentially, and you're not going to be necessarily alerted to that. Whereas under an umbrella, you can't really do that because it's either in one sub-app or another.
Okay, thank you. So thank you, Georgina. A round of applause for